There are three kinds of equations of the line. Well, maybe more, but three that are standard. So if you have y equals mx plus b, that is called the slope intercept form of the equation of the line. I should probably change that to form instead of kinds. Form of line equations. So this is one form, slope intercept. We also have standard. So if we have ax plus by equals c, that is standard. And then we have the point slope, which is y2 minus y, I'm sorry, it's just y minus y1, not y2, y minus y1 equals m x minus x1. Yep. And that is the point slope form. Point slope form. Now, the very same line can be written in different forms depending on the application, or depending on what is given to us, or depending on what we want to do with it. So again, the very same equation can be written in very different ways depending on what is given to us, depending on what we want to do with it, and that's pretty much it. First, let's make sure we know how to go from one kind to another kind. Yeah. So let's say we're given this line, or a line in this form, 1. So let's say y equals 3/2 x. Make sure the x is in the middle, because if you put it too low, then it may be confused with a denominator of having x in the denominator. And x is not part of the denominator. X is next to this fraction. I guess if you have to put it somewhere on the numerator and denominator, it will be less harmful if you put it on the numerator. But it's best just to have it separate. Anyway, so we have the slope, x, and then let's just put some number like -7. Okay, so we want to turn this, which is already in slope intercept form, because there's the slope and there's the number that corresponds to the y-intercept, into, let's say, standard form. In a standard form, typically, we don't want to write fractions, okay? So we multiply the whole thing by 2 to get 2y equals 3x minus 14. So there's no fractions. And then we subtract 3x to the other side of the equation. So we have negative 3x plus 2y equals negative 14. And technically speaking, that's it. That is in standard form. We have a number times x. So what does the form say? Something times x, a number, plus something times y, plus something times y, equals another number, a third number. So there's 3 numbers involved, 1, 2, 3, as opposed to 2. Now, one of the numbers down here could be 0. In which case, if there was a 0 here, then we have to simplify that and just not write it. But anyway, usually though, not necessarily, but usually we want to write the first coefficient as a positive number. So this is not wrong. I wouldn't say this is wrong as a standard form of the equation of the line, but we typically want to write the first coefficient as positive. So multiplying everything by -1 yields 3x minus, because we're multiplying everything by -1, 2y equals positive 14. And that is what I would call the standard form of this equation. Now, I did not change the line. It's not like we're looking for a different line. It is the same line, but it is written differently. Conversely, we got to be able to come from here to there. Let's practice that. In fact, with this very equation. So example 2, let's pretend 3x minus 2y equals 14 is what you are given. Can we come up with a slope-intercept form? And the answer is, well, let's try. So we can move the 3x over to the other side. So negative 2y equals negative 3x plus 14. And then we want to divide by negative 2. So y equals negative 3x divided by negative 2 plus 14 divided by negative 2. And of course, when we divide this side by negative 2, the negative 2's simplify. We have to simplify this answer. So the two negatives simplify, and we typically write 3 over 2 as a number and x next to it. Next to it, not on the bottom. Because if we put it too low, it may look like it is part of the denominator. It's not. It's a number times x. Plus, oh, not plus, because when we divide by negative 2, we end up with a negative number, minus 7. So y equals that is the slope-intercept form. Yep, 3, I was just comparing to make sure we got back the same that we were supposed to get back. So from here, we can go to there. From there, we can get back. That was the second example. Can we go from here to here? It is a little tricky because typically this form is used when they give us a point. So we're assuming x1, y1 is a given point on the line. So again, typically, this is, let's come back to that, to going back into this form in a moment. But let's practice this first differently. Okay, so example 3. Okay, find equation of line through 7, 8, and 3. Let's do something challenging. 10. There we go. 310. Okay. So first we need the slope. The slope equals y2 minus y1, 2, x2 minus x1. So 3 minus 7 is negative 4. So we end up with negative 1/2 after we simplify. So there's the slope. Now, once you have the slope, this gives us, whoops, this equation gives us as an alternative to this equation. We can start out in one of two ways. We already know how to figure out B if we were looking for B here. Okay, so let's do it anyhow. Okay, so one way to obtain the equation of the line is to say, okay, y equals negative half x, negative half, that's the slope, plus b. But we don't know what b is. In order to figure that out, we can plug in this point or this point. Either one is going to give us the same b. So let's plug in the 8 and the 7. So yeah, so 8 is equal to negative half times 7 plus b. I'm going to continue on this page. So that means that we're going to end up with half. So I might just as well change the 8 into 16 halves equals, multiply through, we end up with negative 7 over 2 plus b. So we move this over. 7 and 16 is 23 over 2. That's what b is. So I'm going to finish this up on the next page. So that means the answer, one way to write the answer is to say y equals negative half x plus 23 over 2. So there is the answer if we want to write the answer in slope-intercept form. Okay. Or, since we already have the slope, we can use the point slope form. And that's what I wanted to show you. If we want to find the slope, rather the point slope form of the line, we can simply do the following. The formula calls for y minus y1, so that would be 8, equals negative half, which is the slope we found, times x minus 7. And that's it. So the advantage of doing this is that there is no need to figure out the b. The b is already built into this equation. There is no, I mean, yeah, we can, what I'm trying to say is if we simplify and we try to turn this into a slope-intercept form, the b is already here. It's built into this. We just don't see it because there's some computations we have to perform. But you don't have to set up the problem to figure out b. It's already set up for us. So this would be the point slope form of the equation of the line. If you want to find the slope-intercept form, that is not a problem. We can continue with this. Let's see. Let's distribute. I'm going to do two things at once. I hope that is okay with you guys. So we're going to distribute the negative 1/2 with x. And we're going to distribute the negative 1/2, or we're going to multiply that with the negative 7. That's going to give us plus 7/2. Negative times negative is positive. 1/2 times 7, 7/2. While we're doing that, we're also going to add the 8. So I'm doing two steps in one in this case. So we're going to add the 8 also. Okay, I'm going to think of the 8 as 16 over 2, which is true. 8 is 16/2. And the reason for that is because we're going to combine those two. So y equals negative half x plus 16/2 and 7/2, 23/2. So the beauty of this is that we don't have to solve for b. b, this b number, is already built into the equation. All right. So let's say we want to turn this y, so example 4. I'm probably never, probably nobody's going to ask you this question ever, but I just want us to explore. Let's say you have, 3/2 x minus 7, and somebody tells you, turn that into a point slope form. So we have to have y minus a number, I'm going to put a box, equals 3/2 x. Well, we have to have 3/2 by itself, x minus a number, close parenthesis. That's the point slope form. Well, it turns out that you can put any number that works, any pair of numbers that work. What I would do is simply say, okay, think of a completely random number, but a number that will simplify with it too nicely. So an even number, a random even number. Let me think of a random even number. 40. You know, I didn't want to use 2 or 4, just a completely random number, 40. So if x is 40, again, that's just a random number. What is the corresponding output if we already know this? Well, that's why I wanted to use 40, because 3 times 40 would be 120. Divide that by 2 is 60, minus 7, 53. Let me double check. 3 times 40 is 120. Divided by 2 is 60, minus 7, 53. So if the input is 40, the output is 53. Well, and again, that was just a random number. If somebody tells you, forces you to to write the, we'll see that the thing is there's no the, or it would be an a um, point slope form of the equation. Well, there's many points on the line. There's many points. So just pick one and plug it in here. So y minus 53 equals 3/2 x minus 40 will do. So if I was going to ask this in a classroom with 30 students, I could potentially have 30 completely different answers. You know, one student would say, "Oh, my number is 40." Another student will say, "Wait a minute, I picked 20 instead." Okay, so 3 times 20 is 60 divided by 2 is 30 minus 7, 23. So if another student says, well, y minus 23 equals 3/2 x minus 20, that is a good answer if I was asking for the point slope form. There is as many point slope forms as points are on that particular line. This, as long as we pick a point on the line, we're good. Somebody else could say, wait a minute, I picked the number, I don't know, -8, just to give an, okay, so 3 times -8 is -24. Divide by 2 is -12. Minus 7, -19. So then the form would be y plus 19, because we got to subtract the number. And when we subtract a negative number, we end up adding it, adding the positive of it. So 3 over 2 x plus 8. So I can potentially have 30 different answers, and they all would be good. You know what I would pick if it was me? I would just pick 0 for x, because then you can write, and sorry to put that up here, y minus 0 equals 3/2 parentheses x minus 7. Whoa, no, that's wrong. Whoa. I almost messed myself up. So if we plug 0, the y is -7. Okay, that's better. So if it was me, boy, here I'm telling you what it would be easier, and then I make a mistake like that. So y minus -7 is equal to 3/2, and then x minus 0. There we go. That's another way to do it. It is very unlikely, but not impossible, that somebody will ask you to put this form, because there's many of them. You just pick a random input, and then you get to an output. Yep. So yeah. So it's very unlikely somebody will ask you to do that. It is more likely that somebody will ask you to write an answer final answer in slope-intercept form or in standard form. The most likely one to have is the standard, and rather the slope-intercept form. Yeah. Speaking of random numbers, okay, if you if you are at a point where you don't know how to start drawing any kind of a function, 5, the easiest thing to do is to start plotting some points into the function. So let's say you have y equals something simple, 2x plus 3. And somebody says, okay, draw a picture of this. And you're like, let's say you took algebra a while ago and you don't remember which one the slope is, and you don't remember the y-intercept, you don't remember a lot of things. Okay, just make a table. You know, a lot of students forget, and even advanced students, I have students sometimes in calculus that forget the simplest of things to do. Just make a table, inputs and outputs, something as simple as that. So usually start with 0, because that's a good center point, and then just plugs, and then figure this out. If the equation is simple enough, you can do the computations in your head. 0 times 2, 0, plus 3, 3. 0 times, no, then move up to 1, 1, and put any random numbers. Well, I shouldn't say random. Try to form, I advise to form a sequence. a sequence that has a pattern, so you can hopefully pick up a pattern in the output. That's very, very important in mathematics, to be able to pick up patterns. So if x is 1, 2 times 1 is 2, plus 3 is 5. Okay. 2 times 2 is 4, plus 3 is 7. So then we start thinking, hey, if I continue going this way, 0, 1, 2, 3, it looks like the outputs are going up by 2. So please be conscious of what is going on. You know, there's a 3, okay, and then a 5 and a 7. Can I figure out the pattern? Can I tell what it will be next? 9 based on this, 3, 5, 7, 9. Is it? Well, 3 times 2 is 6, plus 3, 9. Yeah. So now we got a pattern. The outputs keep increasing by 3, negative 1. Well, if that's the case, that means that, no, they don't increase by 3. I did say that they increase by 3, but that was I misspoke. They increase by 2. There's a 3 here. Yeah, because if we were to increase by 3 rather, we would have 0 here, which wouldn't make sense because all of these numbers are odd. So I expect every number to be odd. The next one would be 1, and that fits into the pattern nicely. Negative 2 would be negative 3, and so forth. And then just plot those numbers carefully. Negative 1, 1, so negative 1, 1. And then 0, 3, 2, 3. And then 1, 5. So we're already at 3, 4, 5, and so forth. So then all of a sudden you start looking, oh, I see what's going on. We got a nice line going this way. Yep. Now, if you are more advanced, you will realize, oh, 2, a slope of 2 starting at 3. So start at 3, and then a slope of 2 is 1 and 2 over, and that's it. And then you can draw your line. So there are many ways to draw the graph of a line. Random points is as valid as knowing what each one of the numbers mean. And don't hesitate. Is it time consuming? Sure. Oftentimes we think that in mathematics you have to get to know the answer right away. You know, just give me the problem, plug in the numbers into a formula, and voila, there is the answer. Math is more exploratory than that. It's much more exploratory, much more reflexive. We think, we reflect, we think, we view, we understand, we get, oh, I get this. Uh, yeah, that's the mindset we want to be in trying to understand what's going on, the inputs, the outputs. At first, I have to admit, math is not that easy at first. It isn't. And oftentimes it isn't easy for a while. But it gets better as we go through. Um, a while ago, years, almost 20 years ago, or I think more than 20 years ago, a taxi driver, I was riding in a taxi, and I told him I was a teacher, and he started thinking, oh yeah, math, I like math, but it's hard. And he gave me a good analogy. I thought that was an excellent analogy. I wish I knew the name of the taxi driver, so I can give him credit. And he says, to me, he told me, math is like being in the woods. If you're thrown into the woods, you know, nothing is familiar. You don't know where you are. You don't know where the hills or the valleys, or you don't know where there's an opening, but you get to know one little region, one little area. So if you're in the woods, you know, you get to know just this little part, you know, like, I don't know, 100, no, more than that, but maybe 100 square feet. You get to know that little region. Okay, you know where the tree and the bush and the plants are, and then you extend the radius of what you know. And then you become familiar with exploring that and knowing where things, the rocks, and then you go farther away, and then you get to know that, and then you come back to something that you know really well, but then you go out and explore. And this doesn't have to be concentrical. You know, you can sometimes maybe go this way or this other way and explore over here. But kind of come back to home. I always like to think of this as something that you know really well, like the basic numbers such as 1, 2, 3, 4. You know, so that's how I think of math. Um, you know, do you know your numbers like 1, 2, 3, 4, 5, and -1 and 2, 3, 4, 5, and 0, and you know how to add and multiply and all that really well? Okay, then move on to the fractions, which is already a big leap to go into the fractions. Do we know how to do that? Okay, that's common denominator, and then I gotta to find the least common multiple of the denominators, and okay, but eventually, see, that's exploring and getting farther away. But then there is another direction you can go with just whole numbers. Can you go into the lines, the equations of the line, or quadratic equations, you know? And then you go back to home and you say, okay, I know my integers really well. So, and then you go into trigonometry. The thing is, we gotta be very comfortable exploring um, disciplines. And the same is true with chemistry and biology, I think. You know, you wanna go and explore things away from home. I'm just looking at my notes real quick. Do the homework. That's the best thing I can tell you. Do problems and problems. Practice. Ask questions. View other videos that could very well be much better than mine. Uh, hey, share them with the rest of the students. Hey, I found that you can say something that like um, I found that Mr. Saldivar's video was very confusing, and he talks a lot about stuff that is not even necessary. This other video is going to tell you what it is. Go ahead and share it by all means, please. Um, is it going to hurt my feelings? Maybe, but I'll get over. Don't worry about that. It's much better that that students know what's going on than how I feel. Yep. All right, guys, we're going to stop this video, and that's it.